keynote presentation by Mr. Kishore Narang, Principal Design Strategist and Architect, Narnix Technolabs Private Limited. Mr. Narang has over 45 years of professional experience, out of which over 32 years has been in research and design development in the fields of industrial power, IT, telecom, medical, defense, aerospace, energy, and environment. He's a tech advisor, mentor, design strategist, architect in electrical, electronics, and ICT.
Good afternoon. May I have your attention, please? I think post-lunch sessions are always a little tiresome, and then people are busy in socializing and other things. But I think I'll try to be brief. But I think this is a very, very important topic that we are going to talk about. We are all talking about the current imperative challenges, digital transformation. So what I'm going to basically, with the context of all these aspects, I'm going to focus on the standardization and the architectural approach imperatives for all these aspects, or for particularly digital transformation of utilities. So if you see, we have so many of such shifting perspectives about society's lifeline. Earlier, what we used to do is we used to consider air as essential to even exist and water necessary to survive. But today, the new lifelines are electricity and connectivity. Why? Because electricity has become such a profound thing, we can't survive without electricity. And connectivity is very important, or rather crucial, for us to be socially active, socially alive and vibrant, even for professionally. But then electricity and connectivity have become truly the new lifelines of the mankind. Okay? And energy, especially the electricity, is the golden thread that impacts most of the 17 SDGs of the UN that we always talk about. The United Nations has recognized energy as the cornerstone for economic development, facilitating poverty and hunger reduction efforts, improving healthcare, education, and empowering women. But we also need to seamlessly integrate this paradigm with other two equally important themes, which are fostering a sustainable world and leading on trust, inclusion, and collaboration. However, this journey is full of interesting challenges, and some of them we have been discussing since morning. Next slide, please. Yeah. But we are facing a very different kind of challenges these days. Is this the evolution we expected? Absolutely no. The more we do, the more we progress, the more we hurt the environment, the nature. And as someone said recently, nature no longer runs the earth, we do. Next click, please. Next slide. Excuse me. Excuse me, next slide. Next slide. Yeah. And today, even the future of Earth is in question. Next slide. Next slide, please. So it has been observed that the technologies developed by human beings in the last couple of centuries have had major impact on Earth's climate and even nature's equilibrium. Some believe that we have reached a point of no return, and this can have a huge impact on life on Earth, especially on the human species. Now, however, these technologies have been responsible for this, they also have solutions for all these problems. It is increasingly clear that today's environmental conditions are not sustainable. Over the past few decades, we have made progress fighting disease, poverty, literacy. Now I think we need to use the same ingenuity in solving the problem of global warming and other consequences of human activity. Next slide, please. So technology trends, when we talk about, disruption is everywhere and future is really very uncertain. No one knows what the world will look like even a decade from now. As we head into future, we are surrounded by disruptive innovation. As we look to the years and decades ahead, okay, the pace of innovation is incredibly fast, with new things getting discovered daily. The future trends in technology are very diverse, very intertwined, and very promising. There are several developments that have and continue to shape business strategies, particularly from automation to sustainabilities, are the main focus areas of all the organizations today. Yeah, so taking a peep into the current challenges, these are some of the challenges beyond, in front of us. Climate change, net zero goals and going carbon neutral imperatives and initiatives. Energy securities, example, current challenges that Europe is facing due to geopolitical issues. Clean green energy, coal, gas, oil still meet 3/4 of global heat demand, making it heavily fossil fuel dependent. Energy efficiency is the rightly considered the fifth fuel and source of a clean energy rather than a strategy. Electricity excess, 90.5% in 2020, an estimated 660 million people would still lack access in 2030, most of them in sub-Saharan Africa. Global digital population, internet user 5 billion, social media user 4.65 billion. Growing carbon footprint of digital infrastructure, impact of growing digitalization. Industry 4.0 to Industry 5.0, the shifting perspectives on man-machine collaboration, and sustainability on the forefront for even Industry 4.0 paradigm. Sustainability and resilience, whether electrified or connected, society must be sustainable and resilient to say the least. Greenwashing, need to control the greenwashing initiatives comprehensively. And coming back to our electricity paradigm, we are looking at some interesting shifting paradigms, which are, next click, from a centralized one-way passive energy system today to next, to a distributed multi-way active and predictive energy system. Next. Future network vision, we know from centralized power generation and unidirectional distribution up to best infrastructure with arbitrary energy flow. Next. And flexibility is the new target. Next. Load, storage, and generation management is at the center of all the utility management these days. Next. So, and when everybody is talking about decarbonization imperatives, energy consumption and production accounts for about 2/3 of global greenhouse gas emissions. 81% of the global energy mix is still based on fossil fuels, a percentage that has not budged in decades. A transition to more inclusive, sustainable, affordable, and secure global energy system is imperative. This must be done while balancing the energy triangle of security and access, environmental sustainability, and economic development. Next. So there are many aspects of electricity or energy where digital technologies have a key role to play, whether you talk about smart buildings, smart communities, or smart cities. Cities are even key for net zero emission future, where affordable and sustainable energy is accessible to all. Next, please. And coming to the digital transformation aspect, we are seeing all the different domains, whether they are smart cities, smart grids, smart buildings, going through 3 classes of transformation. First, the improvement of infrastructure to make it resilient. Second, the addition of digital layer to bring that essence of smart paradigm. And last but not the least, business process transformation, which is actually necessary to capitalize on the investment in smart technologies. Next, please. And the genesis of this all digital transformation is what? It's very simple. Sustainability is the true destination, and resilience is its core characteristics, and smart is merely an accelerator. And not to forget that standards are the chromosomes of the digital infrastructure for digital transformation that we are talking about. And when we talk about the digital transformation, what it is all about? Is it technology? No. It is basically all about, because digital transformation has different implications. Yeah. Next, please. So yeah, digital transformation constant. Normally when we talk about digital transformation, particularly in our power sector utility perspective, we normally talk about IT and OT convergence. But we need to remember that there are 2 more players on the block which have become equally important. First, the network technologies, because communication technologies have become so important, so complex, that they need their own due attention, due respect, and due understanding to bring this digital transformation in a comprehensive and holistic manner. And then IoT becoming so pervasive that whenever you are talking about any consumer-facing aspects, IoT plays a major role. And next, click please. And last but not the least, we have a new whiz kid on the block, the AI. AI is pervasive, it is covering all the aspects. So whenever we talk about digital transformation, please keep in mind that all these 5 set of technologies or paradigms, you need to look at them in a comprehensive and homogeneous manner so that we really do not get carried away by the old tradition of digital transformation of IT-OT convergence only. Next, please. So, as I was saying, what is digital transformation? Is it a technology? No, it is not a technology. Next. 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 Yeah, it's a complex paradigm with domain-specific implication. Next. Because we are living in an ephemeral world. Next. And if you look at the smart cities or smart infrastructure per se, it's a back of envelope calculation, which I did a couple of years back. So we already see that 250 million smart meters we are going to deploy in next few years. And all these smart meters are going to have one communication module. And if we go for RF mesh technologies, we're going to have some about you can say 500,000 gateways or DCUs also. Similarly, the smart street lights are going to use about couple of 100 million communication modules. And if you start adding all these sensors and communication modules in different domains of the civic infrastructure or digital infrastructure, we end up with a very interesting figure of 5 to 10 billion communication modules that we are going to use in our civic and critical infrastructure in next 5 to 10 years. And we are not, this is not considering the consumer and the enterprise applications at all. And, but these figures are very never apparent. Why? Because this market is totally fragmented. These figures are much higher than, what we say, the mobile market. But since it is fragmented, we don't see the number. Imagine if this market gets consolidated by common technologies, common standards, common protocols, our communication technologies and modules and cost will come so drastically down that we will be amazed. Next slide, please. But, so as I was saying, all these current applications across the different domains or even within our own electricity infrastructure, all application domains, they work in silos. Whether you talk about renewable, whether we talk about EV, whether we talk about grid scale, there's no seamlessness in sharing data, information exchange of that. There are a lot of friction points between each solution, one solution to another solution, one application to another application. Next. Why? Because there's a common understanding of the big deal, because people are working from their own different ends and they can't even meet together on the same, on different aspects. Next. And that is where the standardization conundrum comes in. That the beauty of standards is that there are so many to choose from, as Andrew Tannenbaum said way back. In an ideal world, we would have exactly one standard for each task or interface. However, in reality, we have often overlapping or rivaling standards driven by different vendor camps. So what can a stakeholder do? Support all standards? Not too expensive. Wait for one standard to replace all? May not happen. Choose one standard and accept all incompatibility with others? Bad, but sometimes only choice. Next. Next slide. As a result, what do we have? With the plethora of different rivaling standards, instead of a symphony, we have a cacophony of standards. Next slide, please. And the irony is that standards and even SDOs are not at the forefront of solution developers, designers, providers, deployers, or even the users' minds. There are misconceptions on what standards are for, and the case for use of standard has not been made. Most researchers, design engineers, and even startups argue that standard block innovation. In fact, standardization brings innovation and spreads knowledge. Standardization helps define contours of structured innovation, first because it provides structured methods and reliable data to save the time in the innovation process, and second, because it makes it easier to disseminate groundbreaking ideas and knowledge about leading edge techniques. Liberalization and market have great virtues, but they cannot create their own conditions of existence. They must be designed. Next slide, please. So what do we have? Somebody has to orchestrate the symphony of standards. Next slide. In fact, it is unlikely to be which standard, rather which standards, since most of the architectures do not pick one standard, but have a layered approach capable of using multiple standards in the portfolio. And the question we are asking is, will system standard be able to do it? I think people will not be able to read the text if you put the chairs in front of it. Can you put them on the side? Leave it. Put them on the side. Next slide. So what we need today, in such a complex scenario, we need a system approach because multiplicity of technologies and convergence in many new and emerging fields, particularly in the large-scale infrastructure, demand a top-down approach to standardization, starting at system or system architecture rather than at product level. Therefore, the systemic approach in standardization work can define and strengthen system approach throughout the technical community to ensure that highly complex market sectors can be properly addressed and supported. It promotes an increased cooperation with many other SDOs and even relevant non-standard bodies needed on international level. Further, the standardization needs to be inclusive, top-down as well as bottoms-up, because a new hybrid model with comprehensive approach is needed. Next. So we are talking about a new philosophy where we need to bring some kind of harmonization in standards in smart home, building, manufacturing, grid, and cities. And another thing, when we talk about data as the new oil without pollution side effect, then what is the big data? Big data is the crude oil, as it needs a lot of processing before it becomes usable. And standards, as I already mentioned, are chromosomes of smart infrastructure. And when we talk about standardization, one thing that is obviously clear is the interoperability is important. And when we talk interoperability, it is not at any one layer. It is end-to-end layer, right from the basic connectivity to the economic, regulatory policies, and business objectives. Next. And I think all are familiar with this smart grid architecture model. And this is very, very interesting approach to addressing any complex domain. You see these three axes, X, Y, Z. So you keep on changing different axes with different requirement. If you see the domains, now there's the same architecture model I can apply to smart cities, any particular domain within the smart grid. Next slide, please. So now here, only changing the domain on the lower side, we can change it to the electric mobility architecture model. Next slide. Today what we need a strategy framework for unified digital infrastructure before we get into architecture, details architecture stand. And the 4 pillars of the unified digital infrastructure for our utilities could be unified digital strategy, governance and operation, trustworthiness and sustainability. Next. And if you look at the utilities ICT architecture, a simplified view, you see multiple layers. And all these cross-cutting 4 pillars, which are operations, governance, security, and integration. Next, please. So, and you see the layer of information. So these are equivalent of the OSI model. This is how the data and information moves from the bottom to up. Okay, next, and converting data into knowledge and then further this thing. So if we map this very model to this infrastructure philosophy, and so these are 4 different pillars of infrastructure that we could talk about in smart cities or any other paradigm: physical, social, economic, and institutional. Next slide. We see that, next, only the top 2 layers, the things will change with different pillars, different infrastructure. All the lower layers can remain the same or should remain the same. Next. So what we need, what we come up with, understanding the common aspects, we came up with a unified architecture. Next. Merging all the common layers into one unique. Next slide. And this is a very interesting new architecture model instead of the hourglass architecture model, where we have this long stem, where we have 4 different very major layers talking about unified last mile communication. Previous, back. Yeah. Unified last mile communication, standardized gateways, common service layer, and smart city middleware, whether it is a utility or a smart city middleware, which can be standardized across use case and application within a particular domain here. So the evolved comprehensively ICT architecture can be modeled like this. And the interesting part is this long stem is the one that brings in the comprehensive harmonization, standardization, interoperability in the architecture, leading to optimization, operational efficiency, and life cycle cost of ICT infrastructure in smart city or even for smart grid for that matter. This architecture model, beyond reducing significantly the CAPEX, OPEX, and carbon footprint of digital infrastructure, enables a unified and well-architected infrastructure that can be easily designed to be comprehensively resilient and even cyber secure. Next. We also have come up with a last mile unified protocol stack, which is actually applicable to our smart metering also. And we are looking at that. The standards are still under development. Final standards should be released in the next 3 months. Some standards have been released, but final layers have not been done. Okay, next slide, please. And this is the further granular onto the application layer standardization. Next, please. Next. Next. Yeah. So basically, what we are trying to do through this standardization effort, there's a glass wall barrier in the communication protocol in the standards of IoT applications and IoT applications, and which we are trying to now break through the common standards and protocols, and including the standardized data models across use cases and applications. Next. So this is a list of standards which have been already released by BIS around the smart cities, smart infrastructure, which are also applicable to the electricity infrastructure. Next. Next, I think these are some of the lessons from them. So contextualizing all these things to the smart grid standard, why do we need all these? Okay, because we are talking about a lot of flexibility, scalability, that's why we need a architectural approach to standards. Next. And these are some of the domains that need, the reference architecture. We need the architectural approach to address different migration from 2019 to next level, meeting all these requirements in different domains. Next slide, next click. Yeah. Whether we are talking efficient homes, efficient enterprises, smart generation and renewable integration, demand side management, or flexible distribution. All these need a structured architectural approach. Next. And this is a methodology to develop the architecture. Next. I'm not getting into these, another further granular, next level. And these are some sample this thing. I'm not running through. You can go through these slides, which I'll be sharing with the organizers. Next slide. Then we have some, when we talk about metering, we have different aspects. A lot of complications are being added. A lot of new use cases, new P2P integrations are happening. We have multiple HES right now, like one for the mesh kind, one for the from different vendors and from different technologies. Next. So what we need is a universal HES platform. We need maybe whether it is coming through data concentrator or multiple, this thing, we need to standardize whether it is HES, MDMS, and all that. Next click. So these are some further illustration of different architecture that we are evolving. Next level. Next. So these are different quick snapshot into head-end, MDMS. Next. And then further granular. If you zoom into the MDMS, this is what it will look like. Next. Then we look at the application platform. This is what a granular look at that. Next level. So then, again, looking at high-level service delivery architecture. Next. Even next. So these are different snapshots for different approaches, different blocks of the architecture that for the utility that we are looking at in the very near future. Next. So these are looking at these different architectural approaches. What are the basic high-level objectives and technical features? Solution size optimization, container-based approach, massive scaling, central event streaming approach and data lake, high-speed rollout, high-performance database, AI, ML, and image analytics, and multi-cloud, multi-cluster kind of a architecture that we are looking at to bring in the technology transformation, optimal sizing, and cost reduction. Next. And these are some of the methodological process that we need. For process, we need to set the business context properly, define the business rules guiding the technology strategy, create the architectural layers and principal blocks, develop reusable component. These are some granular approaches in the principle, whether today's architectures. So right now we are still living in the old era of ICT architecture for the utilities. I think we need to move to the new software technologies and have a new architecture using the latest technology, latest imperatives. Next. So tell me, so where do we stand? Current practices are these. Utility automation solution architecture driven by their operational philosophy and past spec-in documents. What we are proposing, develop a practical, ready-to-use model system reference guide, capturing core minimum functions required smart grid domain applications, mapping applications interdependencies with existing and future smart grid domain applications. Feed to standardization path long-term, and the benefit would be improved system specification process through standard functional profiles, efficiency in project procurement system, and product systems, allows better mapping of cybersecurity concerns and future grid needs, new actors and services, etc., and enable uniform growth of smart grid landscape in India. Next. So another thing that I would like to talk before I close is the cyber immunity and cyber resilience. We always are very worried about cybersecurity. I think we have recently, in the pandemic-induced digital transformation, we have actually learned new things. The speed of processing of AI system is currently seen as providing protection for infrastructure and network that human operators may not be able to match. So what we are trying to do, we are trying to look at a new paradigm of cyber immunity at every layer that will create networks that are inherently secure and self-learning. AI-induced digital intuition is one of the pillars of cyber security strategy that will allow intelligent adoption and ability of AI system to out-innovate malicious attacks by mimicking various aspects of human immunity will be the line of defense to attain cyber resilience based on both supervised and unsupervised machine learning. These systems will be designed to make right decisions with context-based data, preempt attacks on the basis of initial indicators of compromise or attack, and take intuitive remediated measures allowing any digital infrastructure and organization to be more resilient. Next, please. So, to conclude, what are the system standardization imperatives for our electricity infrastructure ecosystem stakeholders? Harmonization in communication standards, protocols, data models can help optimize the carbon footprint of digital infrastructure. Interoperability and standard go a long way in reducing the compute and communication needs, hence reducing the energy consumption and GHG emissions. Comprehensive frameworks and indices for measurement of circularity, GHG emissions, carbon footprint, and net zero. Next. So the key takeaways are we need to develop a comprehensive approach to sustainability, security and resilience, leveraging disruptive technologies, ethically aligned designs, and adopt a system approach in standardization in complex paradigm. Next. 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 So anyway, I'll not bore you with this, but the basic thought about this is, rather than allowing technological advancements to steer our narratives today, innovation and technology should help us build the bridges between the worlds we inhabit now and the ones we imagine for tomorrow. Next. Next. Thank you very much for a sustainable and resilient future. I'm sorry I had to rush through considering the time and this thing, but I'll be sharing this slide deck which you can go through at ease and come back to me with your question. Thank you.
Mr. Kishore Narang.